Today we're going to look at Chapter 9, Chemical Quantities, and this PowerPoint is going to mostly be how to perform stoichiometry. Now, stoichiometry, what the heck is that? Stoichiometry is the process of using a balanced equation, this is a big thing that you need here, to determine the relative masses of reactants and products involved in a chemical reaction. Okay, so we're going to be given a reaction, or you're going to write one. We're going to be given a starting amount or an ending amount and be able to figure out the opposite. Okay? Now, a couple things that you have to know to be able to do this is you have to be able to use molar mass or formula weight, and we did learn this in the last chapter. You'll see molar mass is MM or formula weight is FW, means the same thing, and this is the mass of all the atoms in a compound. Now, big thing students forget is the unit for this is grams per 1 mole, so whatever the mass is, the number of grams per 1 mole. Now, we can use this grams per mole as a conversion factor. So if I were to add up 5 C's, 10 H's, and 5 O's, I'd get 150.13, and that is how many grams are in 1 mole of the compound. Now, you can also utilize this by going from grams to moles by flipping it, and you're going to see how we use that here in a few moments. Now, another thing that you need to understand to be able to do this is mole ratios. So let's say we have this reaction here. 2H2 plus O2 yields 2H2O. So we can use these coefficients as conversion factors. And remember, when you don't see a number, it's an assumed 1. So we can say for this reaction, there are 2 moles of O2, or excuse me, 1 mole of O2 for every 2 moles of H2. And that is creating these using these coefficients. We can also say there is 1 mole of the O2 to 2 moles of the H2. It depends on what you're trying to cancel out. So you can go from anything that is a product or a reactant to another thing in a balanced equation. It has to be balanced to be able to do this. So you can see all the different ratios you can make or can create that you will utilize when you're doing stoichiometry. Now, let's learn how we're going to utilize those moles ratios in terms of equations. So here we go. We have a reaction, glucose and O2 creating CO2 and H2O. As a review from last chapter, what type of reaction is this? It is a combustion reaction. And so we're going to first approach this problem of how many moles of molecular oxygen, so I like to circle what I'm trying to find, and I like to put a little question mark here, are needed to react with 10 moles of glucose. Now, to start these types of problems, you always start with the number given. You start with the number given. So we are given 10 moles of glucose. Now, you are not expected to know what glucose is. It would be told to you that it is the C6H12O6, okay? So you just have to trust me on that one. Now, we are in moles, and we can go ahead and utilize these mole ratios that we learned above to go from moles of this C6H12O6 to what we're trying to end in, which is our molecular oxygen. So when you're trying to go from one thing to another in a balanced equation, you need to utilize a mole ratio. Now, a mole ratio uses dimensional analysis. The unit you start with here is immediately put on the bottom, and not only the unit, but also the identity. And then what you're going to goes on the top. So we are trying to finish in this molecular oxygen. So again, what you are trying to go to or end in on the top, and what you are leaving unit-wise goes on the bottom, okay? Now, we need to go ahead and put some values in here. It did not erase, okay? All right, so to fill these numbers in, again, we use our coefficients. So the number in front of this C6H12O6 is a 1, and in front of the O2, we see a 6. So we only after we set it up, we put these coefficients in. Now, to solve this, you just go ahead and do the same thing we've been doing for dimensional analysis. You multiply by things on the top, you divide by things on the bottom. So really, this is just going to be 10 times 6 divided by 1, which I would skip. So this gets us 60, and I'm going to go ahead and make that 3 sig figs. Now, my answer is not just 60 moles, it is 60 moles of O2. Okay, especially with this, you need to be showing this, the units. Now, the new thing here is you need to be showing not only units, but actually identities. Because we're changing identities, you need to be very cognizant of writing what you're starting with and what you're going to. Okay, so add that to these list of steps. All right, let's do another one here. So we have how many moles of CO2, this is what we're looking for, can be produced from 2 moles of glucose. So let me go ahead and erase all the stuff that I put up here so we can reutilize that. So we are always going to start with what we are given number-wise. So we are starting with 2 moles of glucose, and again, you don't have to know which one that is. I will always tell you that. So again, we write what we start with. Always what you start with goes below. And again, I don't want to just see moles. I want to see moles of C6H12O6. And what are we trying to end in? Moles of CO2. Then we go ahead and utilize these numbers in front. So there is a 6 in front of the CO2, and there is, again, nothing, so it's an assumed 1. And we're going to end here because we're trying to finish in moles. So we really have 2 times 6 divided by 1, which gets us 12. And I'm going to go ahead and make that into 3 sig figs. And my answer is 12 moles of CO2. Now again, your sig figs always come from the starting value, okay? 3 sig figs were both the starting value for both of those. All right, let's go ahead and do one more. Why don't you pause this video and try to do this one on your own, and then you can check your answer. What I'm starting with, what I'm ending in. Go ahead and get the 3 from here. You do not have to draw these arrows. I'm just go ahead and showing you where they come from. So we can go ahead and multiply 5.75 times 3, then get that answer and divide by 2. And I'm going to go ahead and make that 3 sig figs, so 8.63 when I round that, moles of O2 for that. Okay, so again, you multiply by numbers on the top, divide by what's on the bottom. If it makes you feel better, you can put a 1 under that. Not necessary, but sometimes helpful. All right, now we're going to utilize this mole train station a little bit for this chapter. Again, you don't have to. It's just been something that's worked for students in the past. Remember, my mole train station has the mole in the center. It doesn't matter what side you choose to put grams. And then the conversion factor to go from moles to grams is molar mass, or we know that's also called formula weight. And then don't forget on this other side is particles or atoms or formula units or molecules, and we use that 6.02 number, Avogadro's number, but we're not really going to utilize that side of the train station in this chapter, but we are going to use this grams to moles. Okay, so let's add some steps on to the mole ratios that we were just doing. So calculate the mass in grams of H2. So we're looking for grams of this when we have 6 moles of aluminum. Now, when you see 6 moles of aluminum, you have to realize that's not aluminum chloride, that's just aluminum. If they wanted you to talk about aluminum chloride, they would say aluminum chloride. So you have to pick the exact thing that it is talking about, okay? You can't pick and choose. So we always start with the values that we're given, 6 moles of aluminum. We're gonna go ahead now, to go from aluminum to another thing in the balanced equation, hydrogen, you have to do the mole ratio. But you have to be in moles to do that. So we started off in moles, so we can go ahead and dive right into our mole ratio. Now to get those values in front here, remember the 3 comes from here and the 2 comes here. Now, you do not stop. This is the beauty of dimensional analysis. So you have moles of H2. You're going to go ahead and put that on the bottom because we're not done yet. This is asking us for it in grams. If we stopped now, our ending unit would be moles. Okay, so we need to go ahead and do a quick grams to moles conversion utilizing this step of my mole train station. Now to remind you, whenever you're doing this, you go ahead and put a 1 mole when you're going from grams to moles. It doesn't matter. You do not take into account coefficients at all when you're doing just grams to moles. And then you do the mass of 2 hydrogens. So that's going to be 2.02. Okay. Now how I would do this math, I would take 6 times 3 times 2.02, get an answer, divide by 2. Okay, just to let you know mathematically how that would work. I would do that at the same time I am, just to confirm that you're getting the same answer as me. And the answer I get is 18.18, but I'm just going to go ahead and round that to 2 sig figs, so 18 grams of H2. Okay, do you see how we added on a step here? So not only did we do this mole ratio, but we then went ahead and moved on and added a grams to the end step. Okay, so you have to see where you're going, where you're starting from, how to get there. All right, moving on. let's do another example like this. We are trying to do the opposite now. We are trying to find moles of water. So we're going to go ahead and try to find moles of this. And I like to actually do this to kind of give me a goal of what I'm looking for. And it's going to be produced from burning this many grams of octane. So actually, I'm going to go ahead and underline that. So that is telling me there are 325 grams of this. So again, you always start with the actual number, what you're given. 325 grams of C8H18. Now, can I dive right into this step? No, these are in moles. You have to be in moles before you can go ahead and do the mole ratio, okay? This is currently in grams. We have to go from grams to moles first. You cannot do a mole ratio with grams, okay? So if you start in grams, you have to go to moles. Now, remember, grams to moles is always 1 with the mole, and with the gram, you add up C8 of them times the mass on the periodic table, and H, which there are 18 of them, times 1.01. When I add that up, I get a total of 114.26. Okay? Do not solve. You keep going. So moles of this C8H18. I'm going to go ahead and put that on the bottom. And now I can go ahead and do my mole ratio step to get to moles of water. So do you see here, I had to first go from grams to moles, and then I can do this mole ratio step. Okay, so please look at how these are different. All right, let's fill in our numbers here. So the number in front of the water is 18. The number in front of C8H18 is a 2. Another thing I want to point out, when you are doing a mole ratio, mole to mole, you use the coefficients. When you are doing grams to moles, you use a 1 in front of the mole because that is the weight of just one of them. When you're doing the mole ratio, the green here, you can actually use those coefficients because you're using your balanced equation to go in between things. Okay, that's just a very common error. I like to bring that up. All right, now, how to do the math here? To do the math, I would actually take 325. I would multiply by 1. I would multiply by 18. Get an answer. Click divide and type in 114.26. Get an answer. Then I'd click divide again and divide by 2. Okay, so please try that on your own to make sure you're doing the math right. If you're not doing the math right, you're not going to do it right on an exam. Now, we can finish here because we'd end up in moles of H2O. I rounded that to 3 sig figs. And here we go, okay? Now, if it asked us to go to grams of water, we'd do one more step and go right to grams, which is actually what I'm going to show you in this next problem. So we have a mass to mass, okay? So how many grams of carbon dioxide, grams of CO2, can be produced from burning 25 grams of octane, okay? So we're going to go ahead and write this out. You always start with what you're given, 25 grams of C8H18. Now, you're in grams. I'm asking you now, can you go from the mole ratio? Can you go right to carbon dioxide? No, all right? You need to be in moles before you can do the mole ratio. And the mole ratio is when you go from one thing to another in a balanced equation. So I'm going to go ahead and do this. It gets a 1. Now, we calculated the molar mass already for octane, 114.26. So I'm going to go ahead and cheat and use that. Now, on this test, some of them I might give you molar masses just to save you some time. So just keep an eye out in the problem. All right, now I'm in moles of what I want to leave, C8H18. Again, what you're leaving always goes on the bottom. And what I'm going to, in this case, is what I'm trying to find, carbon dioxide. So these numbers, you fill in from the coefficients. Put a 2 here. Now, this is the one where we're going one extra step. This is about as hard as it gets in this class. So instead of finishing here in moles, we are trying to finish in grams. So we're going to go ahead and go from moles of CO2 to grams of CO2. Remember, when you do grams to moles, it gets a 1. And then if you add up 1 carbon and 2 oxygens, you get 44.01. Okay? Again, you need to have a periodic table to be able to do that. So now, how I would do the math, I would take 25 times 1 times 16 times 44.01, get an answer. I would then hit the divide button and divide by 114.26, hit the answer key, and then click divide by the 2 and get an answer. And again, please try that on your own to make sure you're getting the same thing. I'm going to round this to 3 sig figs and get 77.0 grams of CO2. Okay? So I will just do one more example for you, and then we'll finish off with this chapter. So let's go ahead and continue. So we have 25 grams of NH3, and we are trying to find grams of H2. So this is another mass to mass calculation. So if I were you, I'd maybe pause the video and try to use the previous example as a clue to help you. So remember, moles to grams, you're going to use the molar mass of 1 N and 3 H's. So that ends up being 17.03 here, or actually I believe that's 17.04. Okay. So we're going to go ahead, then we can do our mole ratio because we're currently in NH3 and we want to finish in H2. So moles of NH3 to moles of H2. Go ahead and use your coefficients, and we're going to go one more step to finish this off, and then we'll finish up for today. And again, moles to grams, you use your molar mass of your H2. Again, try to do that math on your own, and what I end up getting is 4.45 grams. Again, no answer is complete without an identifier and a unit. Okay, so hopefully you tried that on your own. So just as a review, what we learned here, mole ratios, and also the big concept is how to use dimensional analysis to solve those fancy stoichiometry problems. You have to be able to go from grams to moles, moles to grams, moles to moles, and then also grams to grams, and that is probably the most difficult one. Okay, thanks for listening.